सो क्वेश्चन है अपने डिस्कस करने हैं इलेक्ट्रोमैग्नेटिक थ्योरी के। द इलेक्ट्रिक डिस्प्लेसमेंट वेक्टर एट द इंटरफेस ऑफ टू डायरेक्ट मीडिया विथ यूनिट नॉर्मल वेक्टर n1 2 कैप फ्रॉम मीडियम 1 and 2 एंड फ्री स्पेस चार्ज डेंसिटी डेल्टा एस इज गिवन बाई। सो क्या निकालना है हमको निकालना है इलेक्ट्रिक फील्ड डिस्प्लेसमेंट वेक्टर निकालना है ना। अब डी क्या होता है अपने को पता है, बाउंड्री कंडीशन में इंटरफेस हो रहा है डाइलेक्ट्रिक मीडिया, ये डाइलेक्ट्रिक मीडिया है ना। कंपोनेंट ऑफ बी एंड डी आर कंटिन्यूस, वी नो दैट। So charge density and how we can define it, d1n minus dn equal to rho f upon epsilon naught. So d1n minus d2 normal component of the d displacement vector will be normal component del s upon epsilon naught, because here given is surface charge density is delta s. So there is no option correct here, okay, because is not given here any option, so no option is correct. Now focus on the next question. An interface divides the value into two regions if there are no charges the interference, no charges on the interface, then components of electric field E are continuous across the interference. Which component of the electric field are continuous? So no charge on interface means rho f is 0. So tangent component electric field will be continuous, not the normal one. When a monatomic gas atom is placed in uniform electric field, the resulting induced dipole moment is, we know P directly proportional to E and P equal to alpha epsilon naught E. For a good contact skin depth, the formula of skin depth is under root 2 upon mu sigma omega. Omega is frequency, so we can clearly see this is omega raised to the power minus 1 by 2. Okay, and same as for lambda. Okay, lambda minus 1 by 2 is same for also. The ratio of the skin depth is inversely proportional to omega, and since mu equal to n lambda, when you put here frequency term, so skin depth inversely proportional to lambda. So after solving this, we are getting 0.408, and the closest answer in the question is 0.597, because we are using approximation here. Okay, we are using approximation. The two charges are placed in air and certain distance apart in a slab of mica is placed in the region between them. Then which of the following will happen? The force between the charges increase, the force in the charges between the charges will decrease. Right? So we know that force in medium will be 1 by epsilon r times of force in vacuum. So it will be decreased by 1 by epsilon r. Now three capacitors are there, series and parallel. So we know series is 1 upon C1 plus 1 upon C2 plus 1 upon C2 C3 dot. So 1 upon C will be inverse of these all. So we will show this, and parallel polar sum up. So answer is 1 by 15. Very easy peasy 12th class question. In 12th class, now CBSE asks more hard question than this, so it's easier than 12th class question. Now a point charge of magnitude Q is at distance d from ground conducting infinite plate. The electricity energy stored in the system is. So we know that U equal to minus Q square upon 8 pi epsilon naught D. So U equal to minus K Q1 Q2 upon 2 are here. So 4 pi into 8 pi हो जाएगा यहाँ पे. So U total will be 1 by 2 of this and minus Q square upon 16 pi epsilon naught D. Electric material energized dissipate of one charge dielectric material is placed in uniform electric field. The resultant E inside the dielectric. So inside the dielectric what will happen? Uniform, non-zero and parallel to E. Now a polarized rectangular electric express thickness 2d is placed between Z minus D to Z plus D. Then the volume bound charge density rho b and surface bound charge density sigma b is on the surface Z equal to dr. So surface bound charge density, what is surface bound charge density? Rho b volume and rho sigma b for surface. What is this? Minus del dot p and p dot n cap. So del dot p dot j cap will be bound charge volume density, and it is surface, so p dot n cap, and it will be p naught. So you can see here a polarized rectangular electric slab we have, and thickness is of 2d and P is this, and it is placed between these planes. So volume bound charge density and surface bound charge density. So volume bound charge density will be 0 and surface bound charge density will be P naught. Why it is so? Because here jet cap direction is there and here normal direction is there. Okay, so n cap will be jet to jet cap P naught. Usually correction of positive charge is considered for constructing Gaussian surface if a Gaussian encloses a collection of negative charges. Then for such surface, what will happen for such surface? Electric field lines are inside the, so D equal to epsilon naught E so what will happen? There are negative charges, so normal component of D will be point inwards. Okay, so D, what is D? D is basically E. The electric field inside a spherical shell of uniform surface charge density. शेल आ रही है तो कितना आएगा? 0 आएगा. The electric field intensity on the surface of a charge conductor. Charge conductor में क्या होता है? Directly normal to the surface होता है, पता है अपने को. क्यों होता है ऐसा? ठीक है, समझ में आया? इसलिए होता है ऐसा, क्योंकि जो फील्ड लाइन्स है वो कहाँ जाएगी? नॉर्मल जाएगी. लाप्लास इक्वेशन ये रही. ये क्वेश्चन कोई नहीं पूछेगा अब. द इलेक्ट्रिक फील्ड ई इज नॉर्मल. गाउस लॉ का सीजीएस में क्या होता है? 4 पाई रो होता है. ये सारा आ रहा है तो गाउसियन सरफेस है. इन द चार्ट डिस्ट्रीब्यूशन इन द फिगर द इलेक्ट्रिक फील्ड एट गाउसियन सरफेस किसके वजह से होगा? ई डॉट टी एस इक्वल टू समेशन ऑफ क्यू अपॉन एप्सिलॉन नॉट. कितना है? 2 कूलम. The magnetic field vector B is always solenoidal because del dot B equal to 0, divergence of B 0, and it proves that single pole doesn't exist. Why? Because divergence of B 0 means field lines will be diverge. Okay. It will not be able to form closed loop. A proton is moved against a coulomb force of an electric field. So the work done will be W equal to F dot ds upon Q upon ds, and the energy required to that work done will be used from the some outside source. Same as potential. Okay. For a surface of Gauss law, stated this from what we conclude total flux to the surface is 0. At inserted point varies, so it is a line charge. Now it's a good question. We have electric field, R value है, cylindrical coordinate system है, the energy stored in 0.5 length दे दी. तो क्या निकलेगा? हमको पता है फॉर्मूला होता है हाफ नॉट स्क्वायर इंटू डी वी. डी वी क्या होता है? 2 पाई आर एल बेल का जो कर्व्ड सरफेस एरिया टोटल सरफेस एरिया एंड डी आर. सो व्हेन यू पुट द वैल्यू यू आर लेफ्ट विथ दिस वैल्यू ऑफ आर चेंजिंग फ्रॉम 0.01 टू 0.05. सो यू आर लेफ्ट विथ 0.2245. log 5 वैल्यू गिवन है यहाँ पे 0.2245. नाउ दिस आल्सो a question, how will solve it? Del 2v equal to minus rho upon epsilon. Let's understand the concept. Okay, so from here you will use, you can calculate v by double integrating this with respect to r. When you are left with v, what will you do? You will get rho. Basically you will get a. You will get rho from here, and from rho you can calculate the charge distribution here. So answer will be Q alpha is Q by Q. When you follow this process, you will get the answer alpha Q 8 pi e raised to minus alpha r. The magnetic flux density at the end of a 1 meter long solenoid carrying a current of I ampere and having turn n will be mu naught Ni by 2. है ना, ये याद देखना यहाँ पे कि एट द एंड है ना, एंड है ना, अगर वो मिड में पूछता तो म्यूचुअल एन आई होती। ये अपना मैग्नेटिक इंडक्शन है इन डिस्टेंस फ्रॉम इन्फाइनाइट लॉन्ग स्ट्रेट वायर है ना, क्या होता है म्यूचुअल इक्वल 4 pi d sin theta 1 plus sin theta 2, व्हेन द वायर गोज टू इन्फाइनाइट इट विल reduce to pi by 2, so when you put pi by 2 you are getting 2 and 2 to cancel with 2 pi by म्यूचुअल इक्वल 4 by 2 i by dk। जो इलेक्ट्रिक फील्ड इन फ्री स्पेस, क्या होता है फ्री स्पेस में कंजर्वेटिव नहीं होते, कंट्रोल भी नहीं होते, म्यूचुअल परपेंडिकुलर हमेशा होते हैं, और ये के बाद ऑर्बिटल मूविंग चार्ज द रीजन इज जीरो बिकॉज बोथ आर परपेंडिकुलर टू ईच अदर। नाउ ए चार्ज क्यू इज लोकेटेड एट द सेंटर ऑफ हाइपोथेटिकल क्यूब, इलेक्ट्रिक फ्लक्स क्यूब पर अपसरण होता है, पता है सबको, तो बच्चे को पता है। द वॉल्यूम इन सिलेंड्रिकल कोऑर्डिनेट बिटवीन r equal to 2 meter and r equal to 4 meter contains uniform charge density rho, then electric flux intensity d for r greater than 4. So how will you solve it? We know this is the equation. So from here you can calculate q equal to d into 2 pi r. So just put q equal to rho into v d into 2 pi r. So if you put for r equal to 4, r1 square plus r2 square, this is our given cylinder. So when you put this for 0 to 2 meter, you are having the exact answer like this. But he in question he is asking about the distance a point which is situated at r greater than 4. So how will you calculate for this point? So just again repeat this process, rho into v pi r square h into d into 2 pi r n. So rho pi, what is r square? R square is equal to 16 minus 4, r greater than 4. Okay, so 16 minus r1 minus r2 square, 16 minus 4. So what we are left with 12 and d 2 pi l यहाँ पे, just when you solve it you are getting this. Hope you got this. This is 4, this is 2. 16 minus 4. Now a point charge q is located on the surface of a sphere of radius r. The average electric field क्या होता है, kq upon r square माइनस n कैप। के क्यू आर तो पोटेंशियल होता है, इन्फाइनाइट नहीं हो सकता, जीरो नहीं हो सकता। ए मेटलिक स्पेयर रेडियस आर, चार्ज क्यू, डायलेक्ट्रिक शेयर है 2 है ना, इनके बीच में डायलेक्ट्रिक कांस्टेंट भरा हुआ है, थिकनेस कितनी है इसकी, डेल्टा है, आउटर रेडियस r2 है और इनर रेडियस r1 मान लो। द मीडियम एल्सो इन द पोटेंशियल निकालना है, कैसे निकालेंगे पोटेंशियल, ई डॉट डी आर, ई रख दो यहाँ पे, क्या होता है ई के क्यू अपॉन आर स्क्वायर, क्योंकि आउटर सेल पे निकालना आर ग्रेटर देन r2, बाहर निकालना है अपने को, रख दो, सोल्व करें के क्यू बाई आर आएगा, के क्यू बाई आर। ये सब कंफ्यूज करने के लिए दिया है ना। यूनिफॉर्म कंडक्टिंग स्पेयर ऑफ रेडियस आई प्लेस्ड यूनिफॉर्म इलेक्ट्रिक फील्ड यू नॉट जेड एक्सिस परपेंडिकुलर टू आउटसाइड पॉइंट सी गिवन बाई वी, ये तो अपने को निकालना है, क्या निकालना है, द चार्ज डेंसिटी ऑन द सरफेस। कैसे निकालेंगे, वही सबसे पहले ई इक्वल टू माइनस डेल वी निकाल लो, और सिग्मा क्या होता है अपना ऑप्शन नोट ई होता है, ये चार्ज डेंसिटी आ जाएगी सरफेस पर। सो इक्वल टू माइनस डेल वी डेल आर इंटू आर कैप। सो ई नॉट व्हेन यू सोल्व दिस इज, सो माइनस विल बी कमिंग आउट, माइनस प्लस, एंड व्हेन यू मल्टीप्लाई दिस आर कोस थीटा, सो आर विल बी ऑन कोस थीटा, आर क्यूब ऑन आर क्यूब, तो -2 अपॉन आर क्यूब कोस थीटा, सिंस आर कैंसिल होकर R2 आएगा। सो R2 का इंटीग्रेशन क्या होगा, 1/r स्क्वायर का -2 अपॉन आर क्यूब कोस थीटा। So when you are asking about the surface it r equal to r, so this will be cancelled out, or 2 cos theta plus cos theta 3 cos theta, and when you multiply it with upside note you are getting surface charge density sigma. The total electrostatic energy of a system of a sphere of radius r with uniform charge density q within given by 3/5 q square upon r, 3/5 q square, we know that. Now the region between two concentric right circular cylinders contains a uniform charge density rho, then potential. So same 1 upon r del by del r square del v upon del r minus sigma upon epsilon naught. So when you solve this will go the side, and when you integrate this it will be minus sigma minus rho r square upon 2 upon epsilon naught plus a, and when you divide it with r minus rho r upon 2 epsilon naught plus a by r, so we will be integration minus rho upon 2 epsilon naught r square plus a log r plus b. Now again a point charge q is situated distant d from the center of grounded conducting sphere of radius r, d less greater than r, value of the image charges q prime and distance b from the center, the quantities q bar will be So here you can solve this, but in exam you have to remember this type of question, okay, because it takes almost 5 minutes to solve this question, so you don't have 5 minutes there, okay. So just remember this. B dash in this situation, this is the q, this is q bar, distance is given by, so q prime will be qr by d and r square by d will be b. So this is the point p1 and this point the p2. So at p1 what will kq by r, kq prime by r equal to 0. At p2 what will happen, kq upon d plus r, kq prime upon r plus b equal to 0. So from solving these two questions, what will you get? Q bar equal to minus q r minus b, d minus r 3. And when you solve this 3 and 2, you are getting this, and b equal to r square upon d. And when you put b square upon this equation 3, you are getting q h q r d. So look at this question. This is the theoretical type question and taking too much time to solve this, and this much time you don't have any examination. So just have to remember this part. And our paper, assistant professor paper, has 150 question in 3 hours. So most probably he will not ask you like this type of question. He may ask you this type of question, but time goes. He asks you this type of question, then simply leave it. You don't have to do all the question correctly. Consider a closed hollow conductor of infinite conductivity and observe A and B charge Q inside and Q inside and B Q outside. So the observer would, or what will A observe only A inside. So what will A observe? A observe only the electric field because of the inside the charge Q, but B is outside, so it will observe the electric field because of capital Q and inside field also. Consider a conducting cylinder. Electric field is given. Rho component electric field is the result of the cylinder is given. So rho component B cylinder है तो rho phi और z होगा, ठीक है. When you solve it, you are getting a square upon rho plus 1 ex cos phi. The portion energy of a system of two particles given by equilibrium निकालने के del v upon del r 0. So del by del r. Solve it. Differentiate minus 2 upon r cube minus 8 upon r cube. Easy piece of question. A cylinder conductor placed uniform filled with Laplace equation of the potential V at given cylinder is given by V equal to this. So when you solve Laplace equation, del 2 equal to minus rho plus naught, so equal to minus del V. So just put here equal to minus del V minus del upon del R in V. So again solve it. We just have solved it earlier. Same question repeated. This is repeated. If a straight wire carries a current I and lies along the axis of circular loop, radius r, then the magnitude of the force in the loop, simply it will be 0 because axis along lies in the axis. So I dl cross b sin 0, so theta is 0. If it was normal to the axis, then will be sin 19. We can calculate the value, but in this condition it will be, answer will be 0. If you are thinking that my voice or my speed is too fast, just slow it down, okay. Speed is slow it down and you will get clear cut idea. I'm explaining everything, but if you are not able to understand and have a problem with my speed, just slow it down in the speed limit. So the radius r of a loop carrying conductor I is doubled r to r while the current is halved. The magnetic moment m of the, what is m? So it is proportional to I and r square. So when I is half and r is r square, so 4r square. So after solving this, you are getting 2m. Again same question. You are having electric field. The work needed to charge move. So W equal to F dot dr and F equal to minus QE. And E is given to us. So just integrate r to r over 2r minus KQ by dr minus KQ log 2. Very easy peasy, and this type of question he may ask to you. Okay, this type of question he may ask to you. When negative charge is placed at the center of the sphere, then the direction of the electric field on the Gaussian surface radially inwards. Two thin conducting half planes at phi equal to and phi equal to pi by 6 are insulated each other in longitude, given that the potential function 0 to pi by 6 and V, the energy stored between the half planes free space. So calculate E, and E is this because this is 0 and only phi. Put in this formula half sum naught E square dr, and when you solve it, you are getting 1.51 nanojoule. Look, these are very complex questions because of this calculation. he is not offering you the value of log 0.6. Okay, and like me, you may also not know the value of log 0.6. So I don't think this type of question is feasibly solvable in an exam. If he given to you calculator or computer based examination, it may be easy, but if it's not like this, then it is not possible to solve this question without the giving the value we require in the question, look like 0.6 and 0.6 and 6. Now, the electric incentive for point region between the two concentric conducting spheres, the inner one being held at potential V0 and the outer being grounded is. So what will you do? Simply get V with the Laplace equation. Del by del R is equal to del by del R. So minus A by R plus B. Solve it for both points. And when you solve this equation, you are getting this 2 and A V0 by B minus A, B upon R minus 1. Next question, a cylinder conductor of radius 2 mm, the current density varies with the distance. So I equal to Z dot ds, Z is cos theta, and if you using ds, then R dr d phi. Let's put this, and we are link the value 7.5 per ampere. A long cylinder conductor of radius R and sigma equal to K is a conductor I equal to n sin ds is a function of radius, then the current would be 0. A long wire in semicircular loop, magnetic induction. So these are both wires on the axis, so because of the axis 0, and this is half semicircle, so mu 0 upon I upon 2r, and mu 0 upon 2 upon 2 are equal to 4r. For full it's 2r, and for half it is 2 by mu 0 I upon 2r for full, and half of this will be for semi. Now 8 electric dipoles of charge magnitude E placed outside the cube, the total electric flux will be 0. Plus minus will be cancelled out, so Q will be 0. Which of the following conditions of electric potential is incorrect? It is must be discontinuous across any boundary. It must be 0 if boundary is earthed, must go to 0 at infinity if charge distribution is infinite, must be constant through any conductor, and it must be discontinuous across any boundary. So this will be incorrect, it must be continuous. The interaction energy of a system of charge Q, ये अपने पता है माइनस 1/2 QI QJ upon RA minus RB. Remember ना, very easy piece of question, but if you don't remember options में confuse you. माइनस 1/2 कहाँ से आया? अब बताओ, अपन पढ़ चुके हैं अपन, बताओ ऊपर लेक्चर में पढ़ा था मैंने, माइनस 1/2 कहाँ से आया? 3 पॉइंट चार्ज है, दैट फिट 8 पॉइंट चार्ज क्यू एनर्जी, ये पॉइंट पी चार्ज पे निकालो तो क्या होएगा? इसकी वजह से यहाँ 1 कूलम रख लो, इसकी वजह से किधर आएगा? अपोज होएगा, इसकी वजह से भी अपोज होएगा, इसकी वजह से अट्रैक्ट होगा। तो -2 क्यू को ऐसे निकालो और पी पी वैसे निकाल के इन सबका सम करो, वो आ जाएगी 6 क्यू अपॉन 4 पास नॉट जेट के ऊपर इसको लगा के निकालना है ना। नॉन कंडक्टिंग यूनिफॉर्मली चार्ज क्या होता है? इनसाइड में ऐसा होता है, आउटसाइड में क्या था? ऐसा होता है के क्यू आर अपॉन आर क्यू और रो आर अपॉन 3 एप्सिलॉन नॉट, एंड आउटसाइड विल बी के क्यू अपॉन आर स्क्वायर. Now, in a finite line charge distribution P and Q points shown in figure, the ratio of electric field P and Q equal to 2 upon lambda depend on this, not this. So for both these points age same, so ratio is 1 to 1. Measure I upon to R. बच्चे को पता है. Infinite long closely bound solenoid case solenoid non zero inside and zero outside the solenoid, हमको पता है. और उसके सेंटर पे हो गया म्यूजियर ए नहीं, वो एंड पॉइंट पे कितना होगा? म्यूजियर ए बाई 2. वो इनफाइनाइट पे जाएंगे तो क्या बचेगा? 0 बचेगा ना. वेरी इंपॉर्टेंट क्वेश्चन है ना, ये आ सकता है क्वेश्चन एग्जाम में. जो क्या बोल रहा है, वोल्टेज वी पे था, विच देन द करेक्टराइजेशन बिटवीन, सो डिस्टेंस बढ़ा दिया ना, कुछ भी नहीं करा, बस खाली डिस्टेंस चेंज कर दी, तो क्या होगा, ई का फॉर्मूला क्या होता है, ई नोट अपसाइन नोट, सो अपसाइन नोट इज नॉट चेंजिंग, सो इलेक्ट्रिक फील्ड भी सेम, बट एनर्जी इज हाफ सम नोट ई स्क्वायर इन हाफ सम नोट ई स्क्वायर डी वी, वॉट इज डी वी, डी इज वॉल्यूम, सो इफ वन डायमेंशन इज चेंज देन this will also change, so it will be W2 equal to 2 times of WE1, and only one dimension is changing, okay, dx dy dz, only one dimension is changing, that's why it times doubled, because it's changing 2 times. C is A epsilon upon D, D is 2 times, so C will be half time, and V equal to Q by C, so C is half, so V equal to 2. As per observed volume charge density, the electric potential point R less than R in touch of the sphere.